Good morning, students. In our previous class, we discussed about ionization potential and even what are the factors affecting ionization potential. Right? Now, regarding competitive exam point of view, how they are asking questions based on ionization potential. Few questions I think yesterday we discussed. Let us discuss the other model questions. Right? In before that, now, using the ionization potential values, let us discuss how to find the number of valency electrons in a element. Okay? So, keep this subheading as calculation of number of valence electrons from ionization energy values. Okay, keep this subheading as calculation of number of valence electrons from ionization energy values. Okay, so if they give ionization energy values, so how to find out how many valence electrons are present? Because when we come to know how many valence electrons are there, automatically we will guess its oxidation state. Even sometimes even we can guess the position of that element in the periodic table also. Means to which group it belongs, we can identify. Once if we identify, we can guess the remaining properties of the element also. Okay? So that is why this is a very important concept. So listen carefully. So before going to discuss about how to find the number of valence electrons, so first let us focus when an element has high ionization energy. Okay? For example, look at boron. We know boron atomic number is 5. Boron electronic configuration if you observe, it is 1s2, 2s2, 2p1. Okay? So this is the electronic configuration of boron. Now, the first ionization energy of boron, nothing but what? It is the amount of energy required to remove this electron. Okay? So the last electron which is present in this p orbital. So to remove that one, how much energy is required? That is known as first ionization energy or ionization potential. Now if I ask you to compare with this second ionization energy, this concept we already discussed. In case of any element, when compared to remove the last electron, to remove one more electron, definitely it requires more energy. Okay? That is a well-known fact. Now if you observe IP3, so definitely it is also more than IP2. IP4 if you observe, so definitely we already discussed about that. Because after removing the electrons, the effective nuclear charge will be increases, right? Because the number of electrons decreases, so effective nuclear charge increases. So the remaining electrons will be strongly held by the nucleus. So we should apply more amount of energy to remove the electrons. So that is why all the cases, this IP4 greater than 3 than 2 than 1. This concept will be. Here, my question is, I will give the answer, then based on that we will discuss. So practically if you observe the values, if you observe the ionization potential values of boron, so the order is same, but the difference between IP3 and IP4 is very high. Okay? So IP3, IP4 if you observe, there will be large gap between the values. Okay? For example, if IP3 is 3000, IP4 may be 11,000 like that. Okay? So very high amount. So why that much difference is observed? I think now you are able to understand by looking at the electronic configuration. Okay? Because in the case of boron, the number of valence electrons are 3. So it is having 3 valence electrons. Now if we want to remove the 4th electron from boron, from where we should remove? We have to remove from this 1s2 orbital. Okay? So what is the difference between this 1s2 orbital and the remaining orbitals? Here, these two orbitals are present in second orbital. Right? Here, first 3 energy values are corresponding to the removal of these last 3 electrons present in the second orbital. Okay? But regarding the IP4, if you observe, now you are going to remove from first orbital, nothing but the inner shell. In the case of any element, not only this element, in any element, we know it will be easy to remove the electron from this last one because the effect of nucleus on this will be less compared to this orbital, right? Even if you want to remove from this orbital, it will be even difficult to remove. Okay, nothing but it requires very high amount of energy. Once come to this one, when compared to the remaining orbits, it will be very difficult to remove from this first orbit because it is closer to the nucleus, right? Definitely when compared to outermost orbit, the inner shells are closer to the nucleus. So automatically if you want to remove electron from the inner shell, it requires large amount of energy. So that is why in the case of boron, we are observing a sudden jump in the ionization potential values coming to the 4th. Okay? Why 4th value is very high means it is having 3 valency electrons. Okay? For example, in any other element, if you find the sudden jump in the ionization potential values at the second value, okay? For example, second ionization potential is very high. It means the element is having only 1 valency electron. Okay? If you observe the sudden jump in the case of 5th ionization energy value, it means the element is having 4 valency electrons. Right? So, from this, in general way, you can note down one statement and I will give it on the board also. What we can say blindly, if the sudden jump is observed in the nth ionization energy value means the element is having n minus 1 number of valency electrons. Okay? Got the point of it? The sudden jump is observed at the nth ionization potential value. Okay? So it means the valency electrons number is n minus 1. Okay? The sudden jump we observed in the case of 4th ionization potential. So the number of valence electrons is 3. Got it? Okay? So just note down this example. Then at last I will give that point. So I think from this example, most of you may understand. Let us look at one more example or one or two example if we see, we will get clarity. Right? Look at another case. I am going to take the element sodium. Okay. So in the case of sodium, when we will observe a sudden rise in the ionization potential. So to understand that one, first we need to write the electronic configuration of sodium. Sodium atomic number 11. So its electronic configuration is this one. Now, how many valence electrons are present? So this third orbit is the outermost orbit. Now the second and the first orbits are inner shells. Okay. So how many electrons are there in this? It is having only 1 electron. Fe1. So if you want to remove one more electron from sodium, it is easy, 100% difficult, because if you want to remove second electron, second means you don't count from the starting, okay, from the valence shell we have to count. So this last orbit is having only one electron. So if you want to remove one more electron, you should remove from the 2p orbital. So which is the inner shell, okay? Because third shell is outermost, so second shell is definitely inner shell. Inner shell is already having octet configuration, so it is a stable configuration. So no element wants to lose the stability. So that is why the second ionization potential for sodium is very higher than first one. Okay. So we observed a sudden jump in the second value, means it is having one valency electron, right? I hope now you got some more clarity. Then answer this. So let us go with magnesium. As we have already seen sodium, so if you observe magnesium, it is having 3s2. Okay. Now, anyway we know first ionization energy is smaller than second one. Okay. And second one is smaller than third one. Right? Now my question is, in which case you will observe sudden rise in the ionization energy values in the case of magnesium? By looking at the electronic configuration, it is very clear. It is having two valency electrons. So if you want to remove the third electron, you should remove from the inner shell. So definitely it requires very high energy. So that is why in the case of magnesium, we will observe this sudden rise in the case of third ionization energy value. It means it is having two valency electrons. Okay. Now answer the question. Okay, oxygen. Oxygen electronic configuration 1s2, 2s2, 2p4. Okay. Now my question is, when you will observe a sudden rise in the ionization energy value, means where, means between which values you will find a large gap. Okay. So how many electrons are there? Total 8 electrons are there. Out of 8 electrons, there is 6 electrons. You don't think only about 2p orbital. Okay. So somebody may confuse that valence shell means last orbital, not the orbital. It is the orbit. So second orbit, all these 6 electrons are present in the valence shell. So number of valence electrons, how many of them? Out of 8, there are 6 valence electrons are there. So we will observe the sudden rise in the case of 7th ionization energy value. Okay. So 7th ionization energy value is very higher than 6th value. Okay. I hope now you got clarity about this. Note down these examples. Now note down the point. Highlight this point in the notes. Okay. What is the point we need to remember regarding this finding the number of valence electrons? I hope you understood. Okay. The large gap, if when we observe, for example, for the nth ionization energy, if we observe the large gap between the ionization energy value the element is having n minus 1 number of valency electrons. Okay? Or in another way, if the element is having n minus 1 number of valence electrons, then we will observe a sudden rise in nth ionization energy value. Okay? Note the nth ionization energy value is very high. Then the element contains n minus 1 number of valence electrons. Okay? If the nth ionization energy value is very high, it means the element is contains n minus 1 number of valence electrons. Okay? So from the examples whatever I given, I hope you got clarity. Now let us solve some typical questions how they asked in the nationwide examinations based on ionization potential. Answer this question. So note down the question first. First and the second the first ionization energy means we represent with IE1. The second ionization energy we represent with IE2. The first and the second ionization energies of 4 elements A, B, C and D are given below. Okay? The first and the second ionization energy values of 4 elements were given in the question. So whatever we are going to discuss, this question is here previously asked. NEET question. Even JEE also they asked it. Even this is NCERT, the similar type of question we have. Okay? So very important this type of questions. So not only clearly, later we will discuss. So 4 elements ABCD. This is ionization energy 1. This is ionization energy 2. Now, coming to the first values, what they given is next. The exact values what they given in the previous national examination, those exact values I didn't remember, but the same way of values they given. Okay, so here what the value they given is not important. Whether they given 516, the 520 they given or 522 they given is not important. Okay, so observe the way we are solving the question, right? Now these are the values they given. Now the question is, from the above values, which element is likely to be, they asked 4 questions. The first question is likely to be a alkali metal. Okay, alkali metal, and then we give it as a most reactive metal, because alkali metals are most reactive metals. Second one is a reactive non-metal. Out of the non-metals, which is most reactive, regarding the metals, alkali metals are most reactive metals. Now coming to the non-metals, the halogens are most reactive metals. Okay, so instead of asking the question as a most reactive non-metal, they will mention out of the 4 elements, which is a halogen. Like that also they can ask. Or out of the 4, which is noble gas. The last one is metal forms stable binary halide. Okay, binary halide means metal I am considering as M. Halogen means chlorine, fluorine, anything whose valency is 1. Okay. Now this is the question, right? A very big question. Complete board it is taken, but it is not a difficult question. Okay. I already explained to you the importance of this question. It is a NCERT text question, sorry, exercise question, as well as this type of questions they ask many times in NEET, JEE, and even in the statewide exams also. Okay, and it is not a numerical, first of all. The numbers are there, but it is not a numerical, right? So 100% we can answer this one. Now observe this. Whatever the knowledge we have till regarding ionization energy, use that knowledge only to answer this question. So first question is, which is alkali metal? So that is our question. Okay. So now our task is, out of the ABCD, so which one is alkali metal we have to find, right? So what is the information we know about alkali metal? Alkali metals means which group? So we all know they belong to first A group. First A group means what is their electronic configuration? They have NS1. So they will have only one valency electron, right? So when they are having only one valency electron, then when you will observe the Shannon rise, just now we discussed it. When it is having one valency electron, definitely second ionization energy is very, very higher than first ionization energy, right? Understood everyone? And what basis I am saying that second ionization energy is very, very higher than first, because alkali metals present in the first group, they contain only one valence electron. So when they have only one valence electron, to remove the second electron, we should go for inner shell. So it will be difficult to remove. So that is why in case of alkali metals, the second ionization energy is greater than first. Okay. Now come to this table. Now in this table, where we observe the Shannon rise. If you observe here, 1700, 3400, nearly double. 900, 800, nearly double. 2300, 5400, just more than double. Okay, but observe this one, 522, 7300. Okay, so 520 to 7300 is a very large difference, right? Around nearly 7 times or 6 times or 7 times higher value. Okay, understood the logic of that? Not even 7 times. See, here it is 520. Previous all the cases it is just double or just more than double, right? But this one is a very big value. Second highest value is very high. In the case of which element? Element B. So, which is the alkali metal? So, B is an alkali metal. Understood? On what base I am telling that B is an alkali metal? Because in the case of B, the second ionization energy value is very higher than first. So on that base, we can say B is the alkali metal. Now coming to the second question. What is our second question? Which is a reactive non-metal? Nothing but reactive non-metal means it should be a halogen. Okay. So, in the case of halogens, if you observe, they are present in the 17th group. Okay? If you observe halogens are present in the 17th group. Okay? So, they are present nearly to the right side of the periodic table. So, when we are moving from left to right, ionization energy values increases. Okay? Highest values will be for noble gas. Means for 18th group element, noble gases will have highest ionization energy values. So after noble gases, the second highest will be for halogens only. Okay. Now observe the ionization energy values of these 4 elements. The first ionization energy is highest for element A. Okay. Next highest value is for element D. So it means D is halogen. Okay? On what base we are telling D is a halogen? Because the first ionization potential value is quite high. Okay? Not the highest value. Because the highest value is for what? Noble gas. Our third question is that one only. So, element A is noble gas. On what base we are saying A is noble gas? Because it is having highest ionization potential value. Okay? The first ionization potential value is highest for noble gases. Yesterday, clearly written in the notes also. Right? Understood on what base we solved all these alkali metals means? Their second ionization energy is very higher than first. So based on that logic, we have decided B is alkali metal. Highest value of first ionization energy is for noble gases in any period. So that on that base we can say A is the noble gas. Then when compared to the noble gas, the second highest ionization energy is for element D. So on that base we can say D is a halogen. Okay. Now coming to our last question. Now coming to our last question. What is our last question? A metal forms a stable binary halide as AX2 or MX2. MX2 type of binary halide is forming. Where X means what? Halogen. So halogen means its valency is 1. The valency of halogens is 1. So what is the valence of the metal? So from here it is clear. The valency of metal is 2. Then only it forms a halide of formula MX2. Correct or not? Understood? Because how we will frame the formula valency of X, valency of M. Then we will do crisscross. Then we will get the formula as MX2. Right? So first from the given data, it is very clear that the element M is having valency 2. Valency 2 means what? Number of valence electrons is 2. Okay? So in which group elements valence electrons is 2? Because 2 electrons are there, means the electronic configuration will be NS2 configuration. So the element is a alkaline earth metal. Right? Understood the logic of that? It is a typical thing to understand. Given the halogen of formula formed by metal is MX2. From that we know valency of halogen is 1. So very clear. So from the given formula, valency of metal is 2. If they give MX3, valency of metal is 3. So the metal is having 2 valence electrons means its electronic configuration is NS2. This will be matches for a alkaline earth metal, right? So whether it is alkaline earth metal or whatever it is, not the matter. Our task is to find out of the 4 what is the answer. 100% most of you may got the answer, because A is a noble gas, B is a alkali metal, and D is a halogen. So only the answer left is C. Okay? But we should know why we have to choose C as the element forming MX2 type. Okay? When it is having NS2 type of configuration, there will be small difference between first and second ionization energy values. Okay? Anyway, second ionization energy value is higher, but there won't be much difference between first and second values. Okay? And it is an alkaline earth metal. So compared to alkali metals, first ionization energy value is slightly higher, because from left to right, ionization energy values increases. Okay? So based on that, C is the element which forms a binary dihalide. Understood? Reason what base we are saying means, when compared to alkali metal, its first ionization energy value is quite higher, as well as the difference between first and second ionization energy values is not much higher. Okay? Because they have 2 valence electrons. So when we will observe a large gap in the case of alkaline earth metal means third ionization energy value. Okay? Understood this question? Right. Copy this. Okay. Now let us solve another question. Which of the following electronic configuration has lowest first ionization energy value. Okay, which of the following electronic configurations has the lowest ionization first ionization energy value? Okay, so this is also a previously asked question in state-wide exam. Even recently they asked in MCET exam this question. The electronic configurations they given is 1s2, 2s2, 2p2. Second option 1s2, 2s2, 2p1. 1s2, 2s2, 1s2, 2s2, 2p6, 3s1. Okay, so these are the four options given, means four electronic configurations are given. Now their question is, in which case it requires lower energy to remove the electron. I hope now you already chosen the answer. Which option is the correct answer? Option 4 will be our answer. Okay, so out of the four electronic configurations, the last electronic configuration is having the lowest ionization energy value. Okay, got the same chosen the same option or any different option? Once observe this one. If you observe all these configurations, we are going to remove electron from second orbit. In this case also second orbit. Same situation in the case of option C. But coming to option 4, we are going to remove the electron from third orbit. Okay? In all these remaining cases, the electrons we are going to remove from second orbit. But in the option 4, we are removing the electron from the third orbit. So when compared to second orbit, third orbit is far away from the nucleus. So it requires less energy to remove the electron. Okay? Similar to that, answer another question. Which of the following electronic configuration has this time highest ionization potential value? Okay, now the options what they given is the first option 1s2, 2s2, 2p4, 1s2, 2s2, 2p1, 1s2, 2s2, 2p6, 3s1, 1s2, 2s2, 2p3. Right? So these are the four options they given, and their question is, out of these four electronic configurations, in which case it requires high amount of energy to remove the electron. Okay? Just know from the above question, it is very clear. In all these three cases, the electrons we are going to remove from the third orbit, sorry, second orbit. But in the case of third option, we are removing the electron from third orbit. So it will have the lowest ionization energy. So this is not the correct answer in this question. Okay? Now, again doubt. In all the remaining three options, we are removing the electron from second orbit only. Okay? So the same logic don't work here. Then focus. from where we are removing. In all the three cases, we are removing the electron from the p orbital only. Okay? So penetration effect, shielding effect, all these things will do nothing. Okay? Then, on what base we should answer? Observe the electronic configuration. 2p3, if you observe, we know it is having half-filled electronic configuration, right? Okay, so 2p3 is having half-filled electronic configuration. So when any element is having half-filled electronic configuration, definitely it will have high ionization energy. About that clearly we discussed in the previous class. So blindly we can choose the fourth option because 2p1 or 2p4 are not half-filled. 2p3 due to half-filled, due to symmetry in the configuration, it is having some extra stability. So that is it will have the highest out of the four options. Okay? I hope now we are able to solve these type of questions in an easy way. Right? Even there are few other models are there. Okay? Some typical models how they are asking in the national examinations. So those models we will discuss in the next class. Thank you.